Hello, I'm Gaurav Jain. I'm a third year student, CSE. So I'll be taking today's Linux workshop. So first of all, how many of you know what is Linux previously, maybe in your 11th, 12th, or in your early first year? Yeah, anyone? Okay, anyone wants to speak? They can just unmute. Yeah, correct. Uh, so yeah, Linux. Uh, so it is a family of open source operating system, and it is a Unix based operating system. We'll Okay. Now, what is an operating system? With hardware, with your computer, right? Yeah, yeah. So that's correct. So yeah, operating system is a software that acts as an interface between the hardware and the user and the applications. So basically, hardware, if it is the bottommost layer and user is the topmost layer, then operating system combines those two layers. Okay, so that's why operating system, every piece of hardware have some or the other kind of operating system. Yeah, so we can categorize these operating systems into two kinds. So we can say one is Unix type, other is non-Unix type. So the non-Unix type, you might know, the most famous is the Windows. Okay, which you have been using. Like most of you, I believe, are using Windows right now. The Unix type are Mac OS. Some of you might be using, and Linux, BSD, Solaris. Okay, you might have heard these names before. Okay, so first of all, before diving straight into the Linux, we might as well look into some history of Linux. Okay, so the Unix operating system was it was developed by AT&T. I'm not talking about Linux, I'm talking about Unix right now. Okay, so at AT&T Bell Labs, it was first developed by Dennis Ritchie, and it was written in C. So almost all of the operating systems are written in low level languages like C or maybe assembly. So yeah, and the implementation was pretty high level. Like it was very nice because it formed a good interface to for many systems. So that's why porting it or shipping it to other hardware was very easy. So that's why it became pretty famous very in a small amount of time. Yeah, but then it started to sell as a proprietary software. So people were not allowed to use it without permission, or they had to buy it, or they had to take some, some license or some kind of other thing. So many people were frustrated by this. So among those people, there was this Richard Stallman. Yeah, if you have taken computer science in class 12th, you might have some chapter regarding this. So you might have heard this name before, GNU and Richard Stallman. So basically, Richard Stallman started the GNU project. GNU is a recursive acronym for GNU is not Unix. Basically, it is a Unix, but he named it that way. If you know, like Elon Musk also named his flamethrower something like that, not a flamethrower. It's similar to this. Okay. Now, so he wanted to create a open source operating system that is completely free without any license. So for that, he also made the GNU license, which is pretty famous right now. Okay, many versions have been, like GNU public license 3 has been released now. Okay, so okay, but he also made some programs for the operating system, like libraries, compilers, text editor, command line, etc., etc. But the low level elements like kernel, etc., device drivers, that were not, like, they were incomplete or not so apt. so he had to depend on some other pre-made versions of those. Uh, Parallelly, this Linus Torvalds, you must have heard this name, right? So he also became very frustrated from the licensing of then very popular educational based software Minix. So he began to work on his own operating system, and he started making kernel, actually not operating system but the kernel itself. Later then he started the movement, then many people joined him, and together now it is the Linux kernel which we use. So after that they had the GNU's already built tools by Richard Stallman, like the GNU project, and they had the kernel by Linus Torvalds, so they put it together, and then now we have the GNU Linux and the whole Linux family based on that. Like it started from there. Okay, so the components of Linux. So in fact it is true for any software in general that any software might have a kernel. It is necessary, a file system, some system daemons. System daemons will look each of these terms specifically. Okay, the system libraries, user interface, device driver. You might getting some high level view just by the names itself. It's not so big of a deal. Okay, so and various other small utilities which we'll look into. Okay, so let's start with the kernel. Okay, so anyone has any idea about what kernel is? Yeah, you might have heard kernel. You can randomly guess any definition which pops into your head first. Come on guys, speak. Yeah, pretty much. So like in more refined terms, basically kernel is the piece of program that resides in the memory and that deals with very low level things like pretty much everything. So all of your applications which you make, all of the programs, the processes, all of that are handled by kernel. So the kernel include the memory management, the process management, like how much memory should we allocate to which processes, priority scheduling, etc. Okay, device drivers, they communicate through kernel. Like kernel only initiates the communication. So if you can look at this diagram right here, so if we look at the operating system layers, so kernel is at the bottommost level. Okay, then around that we have our device drivers. Okay, then at the topmost layer we have applications which we use, okay, which we see. So we don't generally see kernel, but it's there all the time. Okay, so that is about kernel. Also kernel has most privileges, while the applications have the least privileges. Okay. Now file system. So the second most important thing of an operating system is its file system, how is it handling its file. Okay, so Linux handles file in pretty unique way. Okay, so in Linux you will see this sentence everywhere, that everything is a file in Linux. Okay, by that what do we mean everything is a file? Basically pretty much everything, every device is a file. Directories like the folders which you know, those are files. Then input output devices, print, anything, monitor, screen, everything is file. Whatever you external devices, that are also files, and the files are also files. So basically that is how Linux has designed, like Unix in general has been designed. So in Windows you might see that there is a C drive. Okay, that is the like if there are multiple drives, then they have multiple names on it. Generally C drive is where the OS is loaded. So similarly here we have a root directory. Okay, so this is the start of the tree. You can think of it like a tree. Okay, so now there are various subdirectories, okay, which we'll look into. So first there is bin directory, which contains the binaries. Okay, you binary by binaries means like okay. The second one, okay, by binary what I mean is we'll look into it. Binary files, what are these? Like we'll move into it a little bit after. Okay, now let us look into boot. Boot are the when your computer boots. So the first thing, the first files which are encountered by the OS when you boot up your computer, that are all stored in the boot. Okay, so how your computer boots, like which OS it wants to boot into, and what all things that it needs to make sure while booting. Okay, then there is device. Okay, it stores all the devices. So you can have a look into it. If I just see, these are all the files which you can see at the root. Okay, so bin, there is bin, there are bind. Yeah, hello. Okay, sorry, I just forgot. Okay, yeah, just a minute. Okay, I'll show you later. Okay, this part you just I'll show this after I have completed this part. Okay, never mind. Yes. Similarly, there are files for media, for mounting, like USB, etc., that you mount. Similarly, there are add-on application software packages which are like optional. There are SBin, which are system binaries, which are specifically reserved for system. There are temp folders. So temp folder is temporary folder. Every time you reboot, it is all empty. Okay. Then user folder contains all your user libraries, user defined libraries, which you yourself make. And the main part which we generally consider is the home, which is like your you can consider as your desktop in your Windows system. Okay, so it might seem a bit complicated, but it is way much easier than how Windows handles it. Like there are program files, and then in 286, then in 32-bit and 64-bit, those are different. Similarly here it handles it in its own way, but yeah, this things is you need to remember that everything is a file in Linux, so that makes things little bit easier to implement. Okay, system libraries which are very system libraries are the libraries which are generally written in C or some low level language, like maybe assembly, which are used by the system in order to, these are pretty standard. Like you might have been using C code. Okay, so there you include hash include IO stream in C++, and maybe in C language you include something related to IO. Okay, it could be like for your printing, it could be taking input, etc. So those libraries are system libraries, so they are shipped into your OS. Okay, so when you want to use it, your OS provides those system libraries. Similarly, system daemons, these are the background processes that run. Okay, so for example, when you switch on your computer, your Wi-Fi automatically connects. Okay, if you have already signed into network prior. So how did it recognize, how did it know when to connect, when to scan? Okay, or suppose you change your location from one room to another, and suppose there are multiple Wi-Fi in your house, suppose in campus you are moving. Okay, then it automatically forgets the previous one and reconnects to the Wi-Fi which is in close proximity. So how does it recognize that? So that is all done by some background processes which are running either in your phone, computer, anywhere. Okay, but these are called the system daemons, which we take for granted, but these are very little things which bother if they are not present. Okay, So these are also very important part of an OS. Then we move on to the user interface. Okay, so the user interface can be divided into two parts. One is the command line interface, okay, which you might have you might be knowing PowerShell. Yeah, anyone have anyone used PowerShell, or at least know PowerShell? Okay, in Windows it is PowerShell, in Linux it is Bash or some other kind of shell, generally Bash. Or anyone have used Git Bash? So all these things are command line interfaces. Okay, so there you issue commands which computer understands or the OS understands, and then it gives you output respectively or does the job. Then there is GUI, graphical user interface, which you use like your mouse. Okay, mouse, keyboard, gestures, etc. These are all graphical user interface. When you click, something happens. When you right click, something else happens. Something like that. Okay, that is GUI. So we'll look into CLI in later. First let's have a look at GUI. Okay, so traditionally, okay, you might be like it might be too much for you, but you just need to have a high level view on this. Like these are not that you need to remember. Okay, so very lightly just listen to this. Okay, it's not much. So the X window system is basically when your computer whatever you do, that is mainly done in your processor and RAM. Okay, and all other things like your keyboard, your mouse, your monitor, your Wi-Fi card, network card, anything else, sound card. Okay, that is all external IO devices. Okay, so the main thing when you call your computer, that main two things are your CPU and the RAM. Okay, because that's where the actual computation happens, hence computer. Okay, and all other things are peripherals. So for display, there was this implementation of X window system, okay, or X11, because it stopped its development at version 11, and it's still being like it's still at version 11. That's why X11. So it is a graphical user interface suite. So whatever your CPU commands, like issues commands for your display, so that all etc are handled by this X window system. So when you move your mouse from this location to this location, okay, so your CPU registers that the mouse location from this pixel has to be shifted to this pixel, so it accordingly issues whatever communication it needs to be done, and then this X window system receives that communication and accordingly displays it. Okay, so that's how the GUI works. It is a bit complicated, that's why I am covering this part specifically. So it is very important in operating systems. Okay, the X window systems. In Windows they use something similar to this, like similar implementation, but not X window system. In Linux they use specifically X window system. Okay, so now window manager. So you see your windows, you can tile your windows, like you can open two windows at the same time side by side, or suppose you have these tabs open, so you can swap these tabs, or like they are automatically being placed by the operating system. You are not dragging. You might drag, you might fit it yourself, but most of the things done are automatic. And suppose you open a new window, so how the windows look overlapped or they don't look overlapped, all these things are done by window manager. Okay, so the operating system has multiple windows opened, so each of them are separate processes, so they have their own state, but for them to be displayed together at the same time, that needs to be managed by the window manager. Okay, so some popular Linux window managers, like most of them are GUI, but like obviously this is GUI, but most of them are floating window managers. Like you use in Windows, your Windows gets floated, while some are tiling window managers, like i3 is one famous tiling window manager. I'll show you what's the tiling window manager, how is it different from floating window manager. Okay, basically tiling window manager automatically, like, it doesn't leave any space out, and it is mostly key binding based rather than mouse based. Okay, I'll show you that later. The desktop environment. So all of these things which we have just covered, okay, all that together is called the desktop environment. So basically, when you open your computer, when you just see your home screen, you also see some notification panel, right? You see your the panel at the down which shows time, or maybe connectivities like Wi-Fi, Bluetooth. It shows you battery, gives you battery notifications. It shows you RAM usage. You can control your sound, brightness, all that things, and whatever GUI you can expect. Okay, suppose you right click at the home button, you see all your options like create new window, launch a terminal, etc. Whatever that is all a complete package that is called a desktop environment. Okay, so a OS might have desktop environment, it might not have desktop environment, but usually, like, the most famous OS like Ubuntu or Windows, all these are already shipped with a desktop environment. So Ubuntu, for example, is shipped with GNOME, okay, GNOME or GNOME, whatever you say, and there is also one famous desktop environment called KDE. Okay, so KDE is also desktop environment. So these two were pretty competing at their time when they were being developed. Okay, so now let us move into the command line interface. So now I'll share my whole screen for you to see. Okay, so just now we have looked into the GUI, now we'll look into command line interfaces. So basically command line is very easy. You are just given a shell, okay, and you issue commands, and in return you get the output. So it's not very difficult. You don't need to learn anything. You just need to make sure that you know that something like this exists, and you can always search it up. Okay, so you need not remember all these commands. So let us start with some few basic commands. Like, suppose we want to know the date, so we enter date, we get the date. Okay, suppose I want to know the date in some other format. Suppose I want to know the Unix timestamp. So Unix timestamp is basically the number of seconds which have been like number of seconds since the epoch time, and the epoch time is this 1 January 1970. So they just randomly set one standard time to compare at that time, and that is now Unix timestamp. So basically you write date plus modulo s. Okay, so that will give you the Unix timestamp. So these many seconds have passed. So these are very basic commands like date. Okay, ls means list. So it will list whatever it is in your directory. So suppose if you open your directory, you'll see all these files there. So if I just open my file manager in general, and if I move into home, okay, I hide the, okay, so whatever these directories are there, that are only listed here. Okay, now you can ls in you want to know, suppose which, like, long view of these files. So you pass /l commands. So there you know if it is a directory, who owns it, when it was created, etc, etc. Okay, it is very basic command. Okay, you can get many options here. You can check up the manual page of it. I'll let you know what is manual page. So manual page is basically for any command. If you don't know, you just type man and that command's name, and a manual page opens. Okay, so it contains all that thing that you need to know that the writers have made, all the options, all the, like, basically these minus are the options. Okay, so suppose just I use -l option. So you can see -l option here, use a long listing format. Suppose I want to know where all my hidden files are there. So I I can use minus a flag, so I can combine minus L and minus a flag together. So there can be many other files like options, like there is minus H option, which is for human readable. Okay, so there are many options, so you can look at into. There are also, they might also occasionally include some examples, or you can always check the internet as well. Like if you just Google what does the command means, if you just type man ls, so the manual page are available at web also, so same thing as there on the web also. Okay, so you don't need to worry about remembering these commands. Okay, so that's not a big deal. So suppose let us I want to know where my hidden files also. So hidden files are basically the files which starts with a dot. So if you create a file, new folder or file which starts with a dot, it is termed as hidden, because generally the configuration files which you don't want to see every time you open or you issue some commands like these, so basically there is a convention that if you rename a file to start with a dot, then it becomes hidden. Now I want to know where our hidden files are there. So hidden files are generally populated in the home directory itself, so there are a lot of it. So you can see the hidden files are included this time. So what kind of files are there? There might be some hidden folders, there might be some files. Okay, so this is the basic ls command. Then there is a cd command. So now I have listed all the directories. Now suppose I want to go into my downloads, so I go into cd and download. cd means change directory. Okay, so I move into downloads. Now I again do ls, which means I want to see what is there in ls, but I see nothing because my downloads is empty. Suppose I go into okay, now let us make a directory. Okay, so we can make a directory using mkdir, which is make directory. Suppose I make directory named foo. Okay, so now if I ls, so now it has created an empty directory foo. Okay, now suppose I want to go inside that, so I'll do cd foo, which means change my directory into foo. You can also see this prompt here. Okay, so every time you enter a command, and if it is over executing, then it will show you a prompt again. So here it shows you whichever directory you are currently in. If you want to know the complete file path of the directory which you are in, you can just type pwd. Okay, so now I am first from the root, so the addressing starts from root. So from root I was in home gj initially. Okay, so just as I told you in the file system part, that if you just look at the directory root, so I listed at root, so all these directories are present, which I also showed you in the previous slides. So generally all the user specific data, like the main data, your downloads folder, etc., that are all present in the home directory. And inside home, if you go inside home, then there are many users can be there. So suppose this username is gj, which is my username right now. So this is my home. So if I cd into it, now this is my home. This is where I started. Okay, so by default we are there in our home. Okay, because generally the operating systems are multi-user based. Okay, so it is important from the point of view of servers, because many people might use the same system, but they need to have their own privacy. So that's why they create their different accounts. That is possible in both Windows and Linux. Okay, so we were at our foo directory, so I go inside foo. Now it is empty, so I made using mkdir a new directory foo. Now suppose I want to create a file, so a file can be created using touch command. So if I create a file touch and I name it as bar.txt, so if I now ls, I'll see a new file is created, bar. So this is like just a empty file right now. So suppose I want to read a file bar.txt, so there is a command called cat. Now you don't need to worry about all these commands, like these are very basic commands, and you don't even need to remember these commands. You can just search like how to read a file in Linux, and it will automatically pop that yeah, you can read file using cat command. You can also open the file using less command, all that things. So you don't need to worry about like commands. Okay, just make sure that you get what I'm saying. Okay, so suppose you read it and it was empty, so it didn't output anything. Okay, so now suppose let us write something into this file. Okay, so for writing, either you can open whatever notepad or whatever text editor you are using, but there is also a terminal based text editor. So when earlier, when the development of operating system started, there were no fancy text editors like we have nowadays, like Word you say, or Notepad. Even basic Notepad, that is also considered as fancy to some extent, because they didn't have those kinds of like high RAM, high end computers. Okay, so that time, and GB RAM was also too much, so that's why they need to resort to some terminal based editors. So we'll look into one such terminal based editor now. So it was initially okay, VI terminal editor. Now then some guy also created an extension for it, so VI extended. Okay, so it's called Vim. Okay, so VI is also there and Vim is also there. So Vim is just extended version of the VI. Okay, so you just type the Vim command and then you pass into the file which you want to open. So I want to open bar.txt. So if I open this, so it is empty file. Okay, nothing is there. So suppose I write something into it, like I write hello world. Okay, then I save and exit. Okay, now if I read the file using cat, then it will say hello world, because I just now wrote into the file. So that's how you can read a file. You can create a file, you can create a directory, you can change your directory. Let us look into some other commands, like who am I, suppose. So currently my username is GJ, so that's how computer recognizes me. So if I type who am I, so it will say that I'm GJ. Okay, that is also shown in the prompt. Okay. Similarly, one more command is there, du, which gives me the disk usage. So if I du into this right now, so it will let us go back to our home directory and then issue du. Yeah, so it basically like, because I didn't pass any arguments, so it basically scanned all of my files and told me what is the size of each of the files, and like it scanned the whole tree inside it. So it's just one folder, but it went inside it as well. So if I want to set some depth, so I can just look into suppose I want to set a depth for you. So these are options. Okay, so these all are, when you look at any manual page, you see there are options like these. So options can be short, options can be long. So short means short form, long means long form. So short generally start with single dash, and long options start with double dash. So suppose you want to get the output in human readable form, so you can pass either -h or double dash human readable. So because it is easy to type, we'll use this. Okay. Similarly, it does not require any arguments, but suppose I want to use depth command. Okay, so now it does require argument, like what depth do I do the computer need to output. So let us use this command at our home directory. Okay, so currently I am at my home directory. So if I do pwd, which means spring working directory, so I am at my home. Okay, I list my files, so these are my files. Suppose I want to issue du -h -d and 1, that is just the depth 1, which means just at the first level I want to know the sizes of all my folders. So basically it is scanning, so it will take some time. We can leave it like we can just see that our foo folder is 8 KB. Maybe it is scanning some other folder which is taking too long, so it might be in GBs. So that's why I'll just cancel this right now. I can suppose I can name a particular folder, like here in this case I named foo, so it output 8 KB. Suppose I want to know what is the size of my pictures folder, so gives me that this is 88 MB, this is 1.6 MB. Like even in the pictures, it there were several, like if you open in pictures, okay, someone has to, were you asking something, Sanju? You had any doubt? Okay, everything is fine. Then let us continue. Okay, so in my pictures directory, if I look, there are, these are the folders, these are some images. If I go back, so these were the images in my pictures directory, and I issued a command till first depth, so it gave me for all the folders, like till depth 1 means it will search for depth 0 and 1. If you place it depth n, then for all depths consecutively it will output. So if you want to know just the picture, then you can set the depth to 0, which means just the picture. So overall it is 116 MB. Okay, you might be wondering how did it. Okay, depth is basically if you look a directory as a tree. Okay, so inside directory there might be several other directories. Inside those directories there might be some other directories. Basically folder directories are just folders. So if you want to know just the size of the folder and not the individual size of the subfolders, okay, you just want to know the size of the topmost folder, so overall size basically. So that is, so you can use the depth, you can set the depth. Suppose you want to know each and every folder in pictures with depth 1, so you can set max depth 1. Because this is max depth 1, so it will output everything till that point. So if you set it till 0, see, you can see, and you might be wondering why the size is increasing. So because the because this session is being recorded, and every time like the some size is being added. Okay, that's why. So it's not anything, like it's not some, okay, like it's not any bug. Okay, so perfect about that. Yeah, so if you got it, you ever asked? Yeah, okay, fine. Let us look into some more commands. Like we have already looked into manual. So whenever you don't know any command, you want to know how it is used, you can just search the man page of it, manual command, either on your browser or in the terminal itself. Okay, there is touch command which we have just saw. Okay, then there is another terminal based editor called nano. So Vim or VI is by default installed in most of the operating system, like Linux based of Unix operating systems. Maybe in Mac also it is there. Then suppose I want to delete my files. Okay, like after creating my file I want to delete. Suppose I accidentally created another file called bar1.txt. Okay, now there are two files. Now I want to delete bar1, so I can just delete using rm command. Rm means remove, so I can type rm bar1.txt and that will get removed. So if I now list, so there is only one file. Also you might want to know that you might want to know this thing, that there is no undo in this command rm. Okay, so whatever you are doing, please don't do it very carefully. Okay, don't just issue this command anywhere. That is why there is some restrictions on RF, like if a file is protected or saved, then it asks you to double check if you want to delete it or not, and to bypass that you can use force command. Okay, so if you check the manual page of RM, so there is this force command. Basically it will ignore those prompts and it will say that okay, I know what I'm doing, just do it. That's the force option. Okay, so we'll look at that part. Suppose if you want to delete a directory, suppose I created another directory. Suppose I created a directory named foo1 inside foo. Okay, and I want to delete this directory, so I'm going to use rmdir foo1. Okay, so let's try deleting this foo folder. So let's get back. Okay, suppose you want to get back to change file you moved into change directory to foo. Suppose you want to go to its parent directory or one step back, then the command is dot dot. Basically dot dot is an abbreviation to the parent. It's a shortcut, it's kind of shortcut. So basically dot means the current directory. So if you do cd dot, that doesn't mean anything because you are already in that directory and you are changing your directory to that directory, so that doesn't change anything. But if you do cd dot dot, you go to its parent directory. So now you are at home. So if you now just list, you will see that you can see foo from here, so you are out of foo. So suppose we want to delete our foo directory, but it says that we can't delete it. So apparently if we look into the manual of rmdir, it is only applicable for empty directories. So how should I remove a directory which contains some files? So for that I'm going to use rm only. So basically if you look at the man page of rm, so here there is an option called -r or recursive. So recursive means you recursively remove. So suppose you want to delete something, so you also delete whatever it is inside that thing and then delete the final thing. So you delete it recursively. So suppose I were to delete this folder foo, so it will delete whatever there inside the foo and then it will finally delete the foo. Hope you're getting what I'm trying to say. So suppose I want to delete foo, so I am going to pass rm -r and then foo. If I list, so yeah, it is gone now. So that's the remove command. Okay, let us look into stats command. So let us make that directory foo again, and suppose we want to know some stats about foo. Okay, it is stat, not stats. So it tells me like what was the block size, what is the inode number, how many links are there. So at least 2 links will be there, because one link from foo to the parent and then another link for itself. So suppose if you go inside the foo and you list all the parts, so we know that it's empty because we have just now created it, but still it shows dot and dot dot. Okay, so dot dot, I have dot and dot dot, I have just told you that dot dot represents parent. So there isn't actually any folder in it or any file in it. Like it is, because it is starting with dot, so it is by default hidden, but it is not a file in itself. It is kind of a shortcut. Okay, so suppose if you want to navigate from your child to some upper hierarchy parent, so you can use dot dot. Okay, so suppose I am stuck deep inside anything. Suppose I am stuck here and I want to go to the root folder. So if I check my present working directory, so first I am inside home, then I am inside this gj, and inside that I am in foo. Suppose I want to go to root, so either I can issue command cd dot dot then cd dot dot 3 times, or I can follow a path like structure. Okay, so suppose first I move into dot dot, then I move into dot dot, and then again it's dot dot. So it is relative. So first my parent, then my parent's parent, then its parent. So if I issue this, and now if I run pwd, then I am at my home directory. Similarly, if I want to go back again, So I'll go into home, then GJ, then again foo, and I'm back to where I was. Also please note that the the paths, they can be of two types. One can be relative and one can be absolute. So suppose you are at your home, okay, so relative to you, foo is just one step away, so you can just do foo. Or you can also do, because you are currently at home, you can do foo, you will reach foo. Or you can do /home, then your name, then foo. So this will also give the correct output because it started from slash, so it is kind of absolute. So it is saying that first you go to the root, then home, then GJ, then foo. So that is same thing. Like you can use relative file ordering, you can use absolute, anything, both works. Then let us look into head. Okay, so let me just go inside foo and create a file. Okay, suppose if you just open a file which does not exist using this bin, and then it will create an empty file for you. Okay, so suppose I want to edit this file. Basically, suppose I wrote few numbers. I can read what I wrote using cat. So yeah, I have written 1 to 10. That is correct. But suppose suppose I need to read some very big file, and I don't want to read all of those files. Suppose I want to read just top 5 lines. So what I can do, I can use head command. Okay, so head means just take top head part, and you can specify how much. Okay, this is one thing. Another thing is called piping. So basically this pipe like symbol, this is called pipe. Okay, so this means that when you can basically merge two commands together to form a single command. Like suppose you want to read a file but only top portion of it, so you want to use two commands here. First you want to read the file using cat, and you want to use head command, but you need to use them together. So basically you will pipe one's output as another's input. So I know that cat reads whole file, so it will give me the whole output of the file, but now I will redirect that output, cat output, and I will pass that output. So basically the commands, like the leftmost command's output is supplied to the next command to its right as an input. So now it will be my input head, and suppose minus n, so suppose -5, which means, or -n5, both are same. You can check the manual. So if we check the manual of head, then -n option gives me number of lines, so first num lines. Okay, so let's get back. So suppose I just want to read top 5 lines. So if we check, then it has output just the top 5 lines. So it was 1 2 3 4 5, and you can pipe this indefinitely. So suppose you have choose top 5 lines. Now suppose I want to use tail command on it. So suppose after I have chosen top 5 lines, now I want to choose among that the bottom 3 lines. Suppose I want to read from 2 to 5. Suppose just I want to read 2 3 4 5. That should be my output. So what should I write here? Anyone? I want to use tail command. Tail does exact opposite of head. It reads last n lines of whatever it is being supplied. So what should I write here? I want the output to be 2 3 4 5. Okay, this part is there, this part is correct. Okay, head -n5 because top 5 should be there. Now I want my output to be 2 3 4 5. So after here, which number should I enter? Yeah, 2. Okay, let's enter 2. Let's check. There is no harm in checking. Okay, it just said 2 4 and 5. So what it did, basically, first it all 10 were supplied, then the top 5 of them were chosen by head. So that is kind of this, his head's output was 1 2 3 4 5, and then that was supplied to tail. and for tail it only chose the last two lines, that is 4 and 5. But I want 2, 3, 4, 5, not just 4, 5. So anyone wants to, yeah, correct. So if I enter 4, so it first I chose first 5 lines and then last 4 lines, so it will give me 2, 3, 4, 5. Similarly, suppose now I want to read 6, 7, 8. Okay. Yeah. So what should be the command? Okay. So I want 6, 7, 8. So head N8 and then tail N. What did you say? 3. Okay. But suppose I want to use tail first and head afterwards, then what should be the numbers? Suppose I want this format. 6, 7, 8, same output. Yeah, like you missed by some offset, but that's fine because you want 6, 7, 8. Okay, the new line is also being added, so that's why it basically when you save the file there was an extra new line, so you have to account for that. So now it will be 6, 7, 8. Okay, that is fine. So basically it you can use n times this, or like n number of times. So you can pass it into another head or another tail or any other command for that matter, like not just head or tail. So that's how you combine two commands together. So it's called piping. So output of first command acts on input on second. Another thing is redirection. So suppose I want to extract suppose this thing, and this is my output. Now I want to save this output into some another file, suppose say bar2.txt. So either I can just paste it here, then I can copy it manually, create a new file bar1.txt, go inside it, paste it, or I can do redirection. So that is another clever way. So if I look into bar1.txt, it's there, right? 6, 7, 8. Now I want to, I'll delete this. Okay. Sorry. So there is just this original file, and suppose I perform some operations on it, and now I want to save the output to another file. So just in the file system part, I just told you that everything is a file in a Linux, right? So whatever you are getting in this output, in this prompt, okay, this is called the standard output. Okay, the prompt which is giving you the output, it is giving into your standard output. So that standard output itself is also a file, that you need to remember, because I said everything is file, which means that standard output is also a file. So it was redirecting into some file. So when you get the output, the system is basically writing into a file, and that file is opened in front of you every time. Similarly, if you provide an input, then basically you are writing into some file, and then system is reading from that file. So if I can just redirect this output from standard output to my custom destination. Suppose I want this to be redirected at bar1.txt. Now just note that there is no bar1.txt. So if it is not there, then it will automatically create bar1.txt. So if I enter it, if I execute this command, and if I just list it now, then you see that already there bar1.txt got automatically created, and it contains our desired output. Okay. Suppose I want to change my operation. Suppose I want this just to be 2. So my output should be what? Okay, and now if I execute this command, what should happen? Suppose I want to add to this. So I'm rewriting on this file. So suppose I executed this command, and if I now read bar1.txt, what should be the output according to you guys? Yeah, so basically it will override. So after it overrides, it becomes 6, 7, but that's not what I wanted. I wanted to append it, not override it. So first I'll change back to my original file. This was my original file. I want to append it. So basically if I do this symbol, okay, so this states that I am appending, so it will append on the file. And now if I read the file, so it has basically appended. So these, first I executed this command, then I appended that to the file, so the output got appended. So this is the redirection. So this piping and redirection, like you can harness several commands power into one command. So suppose if you know, if you can break your task into chunks, okay, then the piping is very good. Like it's really handy to implement. Basically you didn't need to write any code, because if suppose you're doing it in some scripting language, because but you knew piping, so it was not that hard for you. Otherwise you might need to have to first open the file, then read it using any something like C or Python. Because you knew piping, it became very easy for you. So you can use these things for your for your daily usage, like not just reading the file, but you can pipe many powerful commands as well. Okay, so this was this piping and file redirection. Now let us look into variable. So as you're looking at this terminal, it is understanding some language, but it is not any known language that we know, like Python or C++. So but it is some language. So it is the shell language, or you can say it is bash, because bash means born again shell. Okay, so this is shell scripting. Basically this is shell language. This is also a programming language, you can say. Okay, but this is generally used for scripting. Like we don't used to write some robust codes, we don't deploy that into server, but we do it for this general scripting purposes. So suppose if you want to execute multiple commands at same time, so you can create a file name, suppose command.sh. You can create a file, name that, and you can write the bash command. Suppose you wrote ls 3 times, and now if you execute that using shell, so basically bash or shell, it is another command, and you provide it with the file name, so it will execute that. So it executed it 3 times, that's why 3 outputs. So whatever is that you wrote inside the file gets executed. So that is another handy thing. Suppose you want to issue too many commands together, you can write it at one place, and then only one time you need to execute that. Okay, so we are talking about that this language itself also like this shell language is also a programming language. So like in general programming language, we have variables, we store variables, we assign one variable to another, we perform calculations. So even here you can do the same. Okay, so suppose you want to assign a variable, suppose you want to assign x is equals to 5. Okay, you can't, so if you put spaces here, it will throw an error. Okay, so you can't. Okay, so you assign generally like this, x is equals to 5. Okay, so now x got assigned. Now you want to read the variable. So if you read the variable x, that's how you can access. Using $, you can access the variable. But if I enter it now, then it will think that it is equivalent to issuing the command 5 like here. So it does not understand what is 5, because 5 is not a valid command. So but we want to print that thing, so we'll use another Unix command which is echo. So echo is similar to print. Okay, so you echo something, you write echo and supply some string like hello world, and it will print that out. So now you want to echo what is there inside your variable x, so you can write echo x, so it will output 5. Okay, now suppose these are normal variables. Okay, now there is something called environment variables. So if I look inside my environment variables, there are a lot of environment variables. Like these are all environment variables. In sometimes in Windows as well, when you install something, you need to set up your environment variables. They say you go to your settings and set your environment variable to this.
So basically environment variables are the variables which are there in your operating system, set by the operating system, like there in your environment, OS environment set up by your operating system, which are used constantly by some background applications. Like suppose all the environment variables starting with ZSH, these are used by my shells. Okay, so this is my shell, this is ZSH, so Z shell, so it is being used by my Z shell all the time. So if I suppose want to change the theme, so I can rather edit this environment, so I can edit it using some file, or I can directly edit it here. So if I want to read what is there, so it is suppose ZSH custom, so it is pointing to the directory, so it is the directory for, like, you need not care what is it, but you just need to pay attention to the fact that the environment variables are being used by the applications, which you might not know, but they are being used. If they are in your environment, then they definitely are being used by some or the other applications. So these are environment variables, these are not normal variables, so these have some global scopes. Okay, so suppose 2 or 3 variables together can use environment variable. Okay, sorry guys, I think I got disconnected in between. So where was I? What was the last part that you heard? Hello? Okay, yeah. So we were talking about the variables. So we want to read some variables, so we can read it using echo. That part was completed, right? Okay, so now, hello, you can hear me, right? Yeah. So suppose we now these are the normal variables. Now we look into environment variables. So environment variables are special variables which are injected into your environment and by being used by the applications. Suppose this shell itself. So if I read into my environment variable, suppose there is this shell called ZSH. So it is having a lot of environment variables. So suppose I want, so it is being used by the environment variable. So this shell in background uses this environment variable. So suppose there is a thing called this environment variable theme, so it is this theme. So this theme is being applied currently to this whole shell. So if I just change this theme, so if I change this value, environment variables value, then the theme would like to something else, to some other theme, then that other theme will get applied to the whole shell. So these are being used constantly. So basically when you don't want your how should I put it, suppose you want to change your variables dynamically, suppose you want to change the behavior of your application dynamically, so you assign environment variables, and suppose you want to change that behavior, then you change the environment variable value directly. So if I change the theme might get changed, but I don't have any theme name at the top of my mind, so it might just crash. That's why I'm not touching it right now. But yeah, if you want to look at your environment variables, so you might also look at this variable env. So if you see, it is currently empty right now because I did not explicitly set any environment variables, but there are global environment variables like these which are already injected. So these are the environment variables currently. These might get like updated time by time, but these are always being used at the back of the software. Similarly, suppose you already set an environment variables. Now you want to unset the environment variable. Suppose let me set an environment variable using the command here, export. So suppose I export, suppose this is the environment variable. So if I look at this is the environment variable, but now I want to unset it, like I want to remove it, so I can do it using unset and the environment variables name. And now if I say echo, okay, then it is empty because it's nothing there. So suppose if you randomly echo some random environment variable name which is not there, then it will empty, like it will give some void output because it's not there. Now let us look at into processes. So everything that you do on your system, so every application that you are running, every process which you are encountering, like suppose this mouse, so this mouse is itself, I move it from here to some other thing, like from one place to other place, or suppose what should happen when I click it, all these things are being managed by some process, okay, some background process. Or suppose you see your screen, so your screen is being displayed, it changes its whatever pixel values are being constantly updated, so those are all managed by some or the other process. So everything which you see, so in terms of storage, in terms of hierarchy, everything is a file, but when you see the tasks which are happening, so whatever happening, that are all your processes in Linux. So you can look some processes. Suppose if I run the ps command, which just lists the processes, so I see that this zsh, this is itself a process, so this is shell which I am currently running in, so this is a process which is getting run, okay. So this is also a process, the shell is also a process. Similarly, this process tree, so this gives me all the background processes tree. So suppose I'm running this Brave browser, inside Brave browser there are multiple processes, inside those processes there are their child processes, basically these are tabs and windows, yeah. Similarly, suppose I'm using zsh, where can I see zsh, okay, never mind, try this, yeah. So it was here, so this is the terminal, okay, alacrity, and inside that this zsh, I am running this shell inside this terminal. So similarly, I am running two of these terminals side by side, that's why there are two of them. So that's how a process tree is made. So a process can create its child process, they themselves can create multiple child process. And suppose if I kill the parent process, then like there are various types of dependencies among the process that they might cascade, if you kill the parent, then all its grandchildren, children, all of them might get killed, or suppose those all become orphan, okay. So you can manage processes in various ways. So everything what is happening is a process, just remember this point, okay. So suppose I look at this thing ps, now suppose I want to kill some process, okay. So let me kill the process. So a process, every process is assigned a PID, which is its process ID. So it is identified by that ID, the computer identifies the process by its ID. So suppose I want to kill the process with PID 382, which is this shell. So if I execute this command, okay, for using PID, okay, then. So if you don't know, you should always check the manual. So here the manual says how do I input. So you can input the PID in this form. There might be some examples down, so maybe kill, suppose I want to kill, which process should I kill? Suppose I want to kill this process, okay, with PID 40030, okay. The process got killed, so there was some background process running and it got killed. Suppose I myself create some random process, suppose this is the process. So this is another command called curl. So suppose you want to create you ping at server, suppose ping just pings at the server, suppose you ping at google.com, so it is pinging here. Suppose I want to kill this process, so I move to another terminal, I search for ping So this is the PID of that ping. If I enter this, so yeah, it got terminated. So that's how you can kill processes. So this was a foreground process, so it was not very hard to, like, I knew that this was running, but there are several background processes, and especially you have this control, like you have explicit control on which process you want to run, which you don't want to run. It is not so transparent in Windows. Like the task manager sometimes don't allow you to kill certain processes. Here you can even you can terminate your root process. You can, like, your computer might crash at the moment you do something silly. So yeah, you have full control on your machine in Linux. So the processes can be of two types: foreground process, background process. So yeah, like this was running in foreground. Suppose I want to make this run into background, which means you go run into background. I want the terminal for some other command. So I can just put an ampersand in front of that particular command, and now this is running into background, although it is still giving me output, but the terminal is free. Like this is kind of different kind of command which is prompt based, but if I do control C here, so if you see control C terminates a process, it is not being terminated because it only terminates a foreground process. So I have to kill this process again. So I kill this process. Suppose if I was running some file like du command. Suppose I was running inside my home directory with depth1. So this was taking time previously, yeah. So it is running in the foreground. Suppose I want to make this run into background, so I can just append an ampersand, and now it is running in the background. Okay, so it is currently running, and this was its PID, so it just gives me the PID in future case I want to access this process. Suppose I want to kill this process, or suppose I want to bring this process into foreground, so I get the job name. So this is the job, like jobs process, basically. Few similarities, although not completely same, but that is irrelevant here. Suppose I want to bring this into foreground, so I can just bring it. So this is the way of referencing. So it might differ, like you can also refer it using the job ID or like using the PID of the process, but here like I can do it using these types of syntax as well. It doesn't matter. Well, you can just check the manual page of FG, you'll know. Okay, so I want to bring this process into foreground. So let me bring this process into foreground. Now this is again brought into foreground. So if I do control C now, so yeah, it gets cancelled. So you can switch the processes from background to foreground. So similarly, you can use control Z to suspend. Suppose I was running this process and I don't want to cancel it, but I want to stop it, suspend it. Suppose I want to run some another important process, I can suspend it. Okay, and then if I want to resume it, then like I can resume it using bringing, like it is already in foreground, but because I suspended it, it got suspended and went into the background. So I have to bring it back again, or I can just kill it. Doesn't matter. So this was the PID. Now it's terminated. So if I look into the processes, okay, it's still there. Okay, it takes some time to terminate a process. Okay, so let us look into some more commands like PS3 we have already looked at. For processes, you can look all of your internal, like all kinds of processes, background, system processes, kernel processes, everything using the stop commands. So it kind of displays a table. You can move up and down into this table, and you see PID right from PID 1, which is the first process that started. So you see it is the system D process, PID 1, system daemon, which is, I was telling you about the daemons in the slides earlier, that when the computer boots up, all the background processes starts from one process, and these processes then spawn their sub processes. That's how like your whole PC become functioning. Okay, Then there are kernel threads, you see k threaded, then all of these low level processes with their PID. One thing to note that is the lower the PID value is, the higher the priority of processes. So suppose if I kill this first process, then my system might crash right away. Okay, so these are PID associated. Then the user who created it, a modified version of that command top is htop, so it just displays it nicely. So now I can see in a tree format. So suppose this was some process, okay, var, so it spawned multiple child processes, then they might themselves spawn some other processes. So suppose here, if you see here in login, this login, it created where did it go, login, here. So in login, then I created a shell, then in shell it issued another commands and all these. So these are like sub processes. So a child can in itself create multiple child processes. It's like this command, just if you want to it also gives you some extra like metadata kind of things, like your RAM consumption, how your process codes are being used, how many threads are there, how many tasks are there, what is the average like time, what is the uptime of your computer, etc, etc. So if you want to just explore more, it's kind of task manager, you can say. Okay, you can explore more such commands on the over the wire. So basically, if you want to learn Linux commands from the start, so you can play this kind of game. So basically it's just a normal game. Here there is a flag hidden at each level, and the flag from previous level is the password to enter the next level, and that's how you like move level to level. And there are, like you can see, almost 33 levels are there. So I can show you just how to start. So the first level is nothing, this is level 0. So just a minute guys. Yeah, okay. So the first level is basic level 0. Here you need to have some one command called SSH. So SSH, basically secure shell, is used to remotely connect to other servers. So because this game is hosted in their server, so you need to connect from your machine to their server using SSH. So this is the host name here given right here. So paste it here, and overthewire.org, and the port is given 2220. So you SSH into, so yeah, it is asking for password. Okay, this is I accidentally, because I didn't specify which user I want to log in, it automatically assumed that I want to log it into as user GJ, but because each level has separate user, it's written the username is bandit0. Okay, so I need to specifically write that this is a server name and the username is bandit0. So I need to write and then separate it by the @. Just you see as how this prompt is, like my username, then @, then my machine name. Here same, you want to SSH into this user on this machine on this port, so you enter it. Okay, now it is asking for the password. They have already provided the password for the first level, so it is bandit0. Okay, so now you are inside there. You see the prompt suddenly change from my prompt to their prompt, so because I am in their server right now. So this, I have just logged into level 0. So now I need to find the flag for level 1. So it is very basic. They have just written that the flag for the next level is in a readme file located in the home directory. I know that I'm already in the home directory, so if I just do ls, so there is a readme file. Now inside that there is a flag. So how should I read this readme file? Anyone? I want to just read this file. What command should I issue? Yeah, so if I just write cat readme, so yeah, it gave me something. Now this is my flag to the next level. So just I log out, I exit out of this server, then I now, because this is how the game is, now I want to log into level 1, so I need to change the user to level 1. Now I SSH into the next user. Now it's asking for my password. The flag for previous level is the password for this level. I just paste it here, and now I'm in the first level. You can see that like it goes like this. So let us try one more level. Okay, so now it's written that the password for next level is stored in a file called dash located in home directory. If I ls, I see there is a file called dash. So I want to read that file dash, but when I issue command cat dot, then the computer understands something different, because this is not a conventional name. Okay, so this part is tricky. That's why you need to, they have like mentioned reading material, like what is a dashed file name, how to read a dashed file name. So it will say you like, because dash is generally used by commands as an option. Okay, because just we see that if we do ls -l, so it will read it like I'm providing cat some option, because cat is also in itself a command. So it might be waiting for that option to appear, and like it isn't responding because of that. Because how can I tell it that if it's not an option, or if it's a file name? So it's the tricky part. So you check, they have also provided the link, so you can either put all the thing into quotes. Okay, so this will also work. There might be some other solutions, because Linux one thing can be done using multiple ways. I think I lost the connection. Okay, no, quotes doesn't work here. Okay, so I might have to use escape sequence, or let us check what is it. Okay, so yeah, I think you can. So you can use redirection, just as we looked into redirection. So there is an output redirection. Similarly, there is an input redirection. So if you want to redirect this dash, so this will now get redirected as an input to the cat. So it is like minus is being redirected as an input to cat. So this works. Similarly, like there may be not just one solution, there may be multiple solutions. Like you know that the current directory name is dot, so I can append it behind my, like I can do this n number of times. It doesn't matter, because after all I am still in my current directory. How many times I append it before this? So I can just use this type of naming. So this will also work, and there might be some other solutions also. Okay, so that's how the game works. Like now I got the flag, now I can move to the next level. So this is a nice game if you want to learn Linux. Okay, if you want to, it like covers very basic commands, like it's not too advanced. It starts from level 0, but it gradually picks up some pace. So then if you go to higher levels, then you can see there are some new commands. Okay, so that's one way to learn Linux. It's nice, that's why I mentioned it here. Okay, now let's move on to our next topic, Linux distributions. So there are a lot of Linux distributions. So we know that there is GNU, there is Linux kernel, then our GNU Linux. But now several of the organization, companies, whatever you say, they have built their own distribution. So over that thing, they added their own desktop environment and their own user interface, etc., and that whole thing together becomes a distribution. So some of the famous distributions are Ubuntu, Fedora, Debian, Arch. So and one there is one thing called Linux from scratch. Basically there you need to compile your own distribution. Okay, so basically very low level thing. So in Ubuntu you can install it within a matter of clicks. Like in like as you move to the more experienced distribution, which means that they require some development experience, like not you need, it's not like you need to code something, but yeah, it is a bit complicated, that's why they call experienced distributions. So there you need to like it's there you get the power of customizability, but at the same time the things become some complicated. So that's why there are variety of distributions present. So this is some like modern day distribution chart, although there are lot many distributions are there, but these are some major families of distributions. So there is a Red Hat family. Okay, so it has their own distributions. Arch family, Debian family. So Ubuntu is a derivation of Debian family. Ubuntu itself has many flavors, like its own distribution. So main one is Ubuntu, and there is KDE. So basically Ubuntu uses Genome as your desktop environment. So suppose if you change that desktop environment for Genome to KDE, then it becomes Kubuntu. Okay, so like these all these flavors are there. Okay, you might have heard Kali Linux. So yeah, it is a Debian based distribution. So rising. So rising refers to the process of customizing. Okay, so when a user, suppose you have finally chosen a Linux distribution, now you further want to customize that distribution to match your own needs. Suppose you need to configure some, suppose as basic thing like as little as a key binding, suppose. Okay, or advanced something like as soon as you log in, you want all your emails to be shown as a notification, suppose. So you can write your own script, or you can use your own tools. Okay, whatever, however you like it. Like you need to you can customize it to your own will. Okay, because you have complete power, because you know how to write code, you know the platform where you can, like, you know how to integrate that to your operating system. So you can do pretty much everything. Okay, nothing is like I don't know, but yeah, everything is possible. I can't use the word nothing is impossible, because there might be some things which I am not aware of at the moment. Okay, but yeah, you can do pretty much everything. Same, suppose you want to whatever you customized, suppose you want to save that state, so you generally save it in dot files. So when I first opened my this file manager, I hid some files. So because these files are hidden files, these are dot files, as I told you that when I generally do ls, these are not visible, but when I do ls minus a with minus a, now these are visible. So these are called dot files. So as you can see, we start with dot, and most of the dot files are configuration files. So you see there is a config folder. Suppose you see here, like there is .java folder. So it contains configuration files related to Java. So suppose there are some fonts. Suppose there is a dedicated folder for config in Linux. At least almost most of the distributions there is. So if you go into cd config, so all apps, generally it's a good practice, like it depends on the developer, obviously, that they store their configuration files in a folder. They create their own directory inside config folder, and they store their own customization. So either it could be customization like the app automatically does, or suppose you can customize it by yourself anyways, but you need some configuration files. So you can take backup of these files, and suppose you want to load your configuration when you migrate to some other PC, so you can easily do it using config files or dot files, as they say. You can rise Linux. Basically this whole thing, like this thing is called rising in Linux community. You can check out this Reddit page. Okay, this has like pretty nice, like awesome pricings, like people post it pretty much every day. So whatever they do, they just post it. So suppose some guy made this customization, so he made it to his, like he liked it, so he made it and he posted it. So you can also check his dot files. They generally post screenshots and link to the GitHub. Okay, so you can check that out. if you like. So that's how rising is done. So people generally who love to customize their things, they store it somewhere. It is generally GitHub, and they share it with others. Like they others can also contribute to their customization, or they can borrow their customization. So you need not to have to do rising by your own. Like you can borrow from from several people and make your own mix. Okay. So for exploring Linux, for you guys to explore Linux, you can start exploring Linux right away. Like even if you're on Windows, you can use virtual machine. Virtual machine means VirtualBox. Like there are Windows software in which you can run Linux, like VirtualBox or VMware. You can dual boot it, or you can use WSL, which is like very popular nowadays because it has become very easy to use Linux inside Windows using WSL. Okay, so you can use any of these options, or there might be some more options available, so you can use that as well. You can start exploring Linux. You can learn command line using over the wire. Okay, and you can this is one poem like generated by ChatGPT. So I asked it to generate a poem for a window user to motivate it to like use Linux. So it generated this. Okay, this will be available in the slides when we share it to you. Any doubts? If you want to ask anything, my name is Gaurav Jain. You can search my name on Gmail. Okay, and you can mail anything. Like if you want to ask anything, you can ask me personally. You can ask it here. You can ask on chat box. Okay. Any doubts? Anything you want to know? If you think you didn't understand. Okay, so Linux is pretty much used everywhere. The servers which you see, the web servers which you see, they all use Linux. They all run some kind of Linux. Okay, so suppose you want to SSH into some server. Okay, suppose you want to change configuration. Suppose you are working at a remote company. Your server is there somewhere remote. Okay, you don't have your server. Suppose you are using AWS. So how will you change the configurations? So you have to use SSH, just like we did in our case. You have to SSH into that thing, and you have to, like, that will be Linux. So you need to know how to use Linux. At least you need to have some basic understanding of Linux. Otherwise, like, it will be difficult for you, because you won't get any GUI there. You have to use terminals. You may get GUI, like there are softwares like AnyDesk, but like generally they are not installed on their server, so like, there is no way you can use it just by yourself. So they use Linux, and basically even in development, like when you deploy your own things, these are generally deployed on Linux. Like obviously almost all, like I've never seen any Windows hosting server. There might be some, but yeah, they are not popular. Like at least at industry level, everything is done pretty much on Linux. Even the development environment which you see, it is in Linux. Okay, window manager from GNOME to something else in Ubuntu. Yeah, you can change it to a tiling based window manager. Yeah, so I was about to say tiling based. So currently the window manager I'm using, it is i3, so it is tiling based. So basically it is not like the dragon, like the floating window manager. It is a tiling window manager. So if I want to change my workspaces, so it has a different concept altogether. So you can check i3 window manager. So it is a tiling window manager. So suppose you want to open something else, few other programs, you can tile it however you like. Okay, like it basically you can stack them together, you can open side by side. It occupies whole of your tiling, like it tiles it, like how you place tiles on your home. It's like that, like it's not floating which you see. It can be made floating, but it is generally useful to navigate. Suppose I want to switch, suppose I have opened it like this. Now I want to move from this terminal, suppose here, to leftmost browser. Okay, So I can use some keyboard shortcuts. For my case it's Windows H, okay, or Windows left arrow. So now I'm in the browser. Now suppose I want to move back to that terminal side. Now suppose I want to move up. So like I don't need to touch my mouse to do that. I can do it merely just using some shortcuts. I want to change my workspace from 1 to 2. I can do Windows 2. Now I'm it's new workspace. So that is convenient if you like, if you are fed up of, like, it is generally faster than using mouse. That's why like people prefer it. There is this styling based window manager. Then in Ubuntu there is by default Genome. Then as I told you, if you use KDE, you can use KDE because KDE is another popular UI based window manager. You can install it on Ubuntu. So KDE Plasma, very famous. Okay, in fact even if you don't want to do that yourself, you can just search Kubuntu. Okay, so it comes with Ubuntu with KDE. So yeah, you can change your window manager to anything you want. Like because it's Linux, you can customize pretty much everything. But that's why you choose Distros, because Distros come with something which is already done by somebody else. So you don't need to do that extra thing which somebody has already did. Okay, so yeah. Installation of Linux, you can do anything. Like for starters, you can go with WSL, because in dual boot you need to make some partitioning and all, then you need to install grub, etc. You can do it if you like it, like there's no harm. But yeah, WSL is like bit easy, and then you can, after you have gained some experience, you have some confidence, then you can switch to Linux completely, whichever Linux you want. Generally people start with Ubuntu. So yeah, anything else? Yeah, recording and slides will be shared, so don't worry. Although I'm not sure about the quality of recording, so pardon. Yeah. Okay, so in the when with the slides, we'll also share you the link, okay, in the mail itself, the Discord server link.